So, hi everyone, and let's go ahead with our today's topic. That will be OAuth authorization and authentication. Specific reason to choose this topic, as you said, this is actually a lot of compliance audit also does that they want implementation of OAuth at the first place and not want to depend on the application server completely. So they want this third party application to be integrated. So we need to pen test this, and that's the reason there are some of the test cases which when I started my journey in cybersecurity, I missed it a lot. And afterwards, I have encountered an issue with, we need to test them third party as well. So I have come up with some of the test cases which I do, and let's go ahead and understand them. So today's agenda will be, we will understand what exactly is single sign-on. Later, today's topic that will be about OAuth, giving an introduction, what exactly it is, what are the key parameters or what are the grant types and everything. After that, specifically focusing on the grant types, which is the important component of OAuth. So if you are trying to understand what is OAuth authentication and authorization, grant types is one of the main things which you need to know about. And after that, going with some of the live demonstration, in which I will be covering two test cases, majorly which I have found in some of my gigs, and then afterwards Q&A session. So the live demonstration will be regarding a CSRF vulnerability in OAuth and something as a client confusion attack. So once you will we reach there, you will understand it. So let's go ahead and understand single sign-on. So what exactly is single sign-on? So as I said, a lot of time the application server or the main, what you can say, the company itself, they don't want to completely solo independent on their authentication, but the auditors or the GRC people will ask them to integrate a third party authentication authorization in which OAuth comes into place. So this is simple. The reason is any user out there who is using Google or what you can say your Gmail address or anything, so they have been gone through their single sign-on. So if they want to authenticate in your application, you simply ask any other service provider, it can be Microsoft, Google or anything, to authorize yourself into that application, and later they will check it with the third party itself. So this is how exactly the single sign-on work, and where you will find this. So major time when you are actually pen testing any application, you go with a lot of authentication flaws. So you will see that you can join in with your Facebook account, you can join in with the Google account. At that moment, it is basically using OAuth or any other authorization framework like SAML. So at that time, majorly OAuth is being used. So this is how a single sign-on can be used, and these are some of the benefits of using it. Convenience, you don't need to implement any kind of authentication authorization, so it is not a your side problem. Afterwards, security, if Microsoft and Google is using it, then it is secure, myth. So after that, then there is a easy user management. Simple. If you are into managing that whatever users are written right now into your application, you can directly call an API from the Google or Microsoft OAuth providers and check it accordingly. So let's go ahead and understand introduction for the OAuth and OIDC. So what exactly is OIDC? So OAuth, you have been understand that this is an authorization framework. Basically, I am Atharva, I have been logged into an application, so I am authorized to do some of the things in that application. But what OIDC do? That is OpenID Connect. If this is added to your scope of OAuth, so it is basically giving you identification. That is, I guess if some of you have been pen tested these kind of authorization frameworks, you would have seen something in response like access token, refresh token and ID token. So OIDC is basically that ID token. It is giving you completely whatever identity that user has right now. So this is the main process. So to explain OAuth in easy way, I have created some of the components in your in an easy format. That is an end user, OAuth client and OAuth server. So end user is everyone, the end user we are working on right now. Then the client is basically the pen testing client, your main client you are pen testing into. And the OAuth server is basically the third party server that client have integrated in their application. Once you understand this process, we'll get to know about the OAuth a bit more. So let's go ahead and understand the flow now. Okay. So these are some of the key parameters which we need to understand in OAuth. So as you can see, there are these are the key parameters. That is, first is the client ID, So client ID is nothing but the audience, or I will say the web application. For example, Redfox have hosted an application and now they are using OAuth as AWS as a OAuth. So Redfox will have a client ID name as Redfox, and their service provider will be the Cognito or anything which is regarding to the AWS. So that is your client ID. Then goes with the client secret. So this comes into picture into one of the grant types of OAuth, that is client credential grant. If you're not familiar with it, I'm also going to that, but I will give you a small overview about what is client credential. In client credential, you don't require any end user to interact with that OAuth server. It is basically machine to machine communication. So what happens in this? You are communicating with your device, you are logging into an application, and now you are communicating with the OAuth server. Now what happens in the backend? The developer have written a code that fetch the secret and the client ID from this environment, add it in your code, and then request to the OAuth server. So in this case, never a end user is into the contact of the web application. So this is where the client secret comes into picture. There is a very great attack for this, actually an easy attack. A lot of time you will find something like client secret in your JavaScript files, or else if it is an in-house OAuth server, a lot of time this comes into picture. The client credential grant comes into picture. They're not using any third-party OAuth server. They build up their own OAuth server and they host in their local labs or local systems. At that time, it is a very high chance that the client secret can be brute forceable. You can easily brute force it and you can crack it. So this is one of the main things. Then goes with the response type. So now, this actually can be explained in the grant types better, but still I'll give you an overview. What exactly is a response type? When you are authenticating, a lot of time there are two things which a OAuth server will give you. One is an access token or an authorization code. So the response type will check what exactly you want. If you set it as a code, it will respond you with the code. If you set it as a access, it will respond you with an access token, that refresh token and everything. So that is basically. Third is the scope, which is the most important part of the grant, what you can say, the parameters. So this basically defines what your JWT can do. Whatever access token you get from the server, what are you capable to do with that? The scope will define it. It will give you tons of things. There is a very good attack. I have not created a lab for that, but I will explain you what exactly you can do. A lot of phishing activities are actually done by this. Then there comes a redirect URI that we all are right now familiar with. When you are authenticating, it is obviously redirecting you to give you the access token and authorization code. After that, there is a state parameter. Now, this is actually not in the, what you can say, parameters. It is added by the client, that is our web application, to mitigate the CSRF vulnerability. Now, I won't go in deep about CSRF. CSRF is basically a user is logged in. You are basically behaving like that user and you are giving them a link to just communicate in their browser itself. So, state parameter will make that request unique. So, you won't be able to perform any kind of CSRF attacks. This is the work of CSRF attack. Then this is a grant type which we are going to cover completely. After that, access token, refresh token and ID token. These are the tokens which are provided by the OAuth server, which are later used to call APIs. Then refresh token is used to get the new access token and ID token is for the complete identification of that user. So these are actually the key parameters which you need to know about the OAuth authorization. Going ahead. So this is the exact flow, what happens when you are authenticating in an application. So this is your OAuth server, this is you, and this is the client application which you are pen testing right now. So when you are trying to log in into the application, if the application have their own login, they will ask you to enter the credentials, or they will throw you at the SSO login, where you need to enter the OAuth server or any other credential. If the client have provided you the credentials, you can enter that, or you can use your own as well. So if you are using the SSO login, it will either give you an access token and authorization code depending on your response type. And once you get the response type, response code, you can just throw back to the main client side and ask them to give you whatever you are requesting for, any APIs or anything. So this is how actually the OAuth authentication and authorization works. I hope this is clear. Any doubts so far? Anything regarding? Yeah, go ahead.
Do you have a sample request or a response showing me?
I can show you in the lab completely itself. Right now, I don't have a screenshots for that. I'll just show you one thing. Okay. Give me a moment. Okay. Okay. I hope this is visible, right? Yeah. Give me a moment. I say this one work here. I'll use this in Burp rather. Yeah. Are?
RP was
Okay, second. Okay. Now it's working. Okay. So going ahead. So wait a minute. I hope this is working. Yeah. So I've created a normal lab. I'll show you what are the exploits for this. From the name itself, you would have understood what I'm going to do with this. But I'll just show you an normal login process. So for this, I'm using Dex as a OAuth service provider. So now Dex will give me all the credential grants or whatever I am asking for. So I'll just show you what you can do for this. I will intercept this request now. Okay. So basically now it is me. I'll forward it. Wait a minute. Now, so when you are actually trying to log in into SSO, if you're already logged in, you will be directly redirected to the main dashboard itself if you when you click into the single sign-on. But now, as there is nothing in my cache, so I need to give whatever credentials the SSO is asking for. So in this case, a lot of time you will encounter Microsoft, Google, or any other service provider. Right now, it's an open source which I'm using as a Dex. So this will be okay. So once you have completed this, Dex will give me a request saying that can I grant the access. A lot of time you will get an MFA kind of thing from Microsoft saying that do I need to grant the access, the yes or no, I am in. You kind of get these kind of messages. So it is basically giving you grant access types. So I'll just intercept this and I'll show you what exactly this does. So basically it is sharing a request with your ID saying that, yeah, this user have been logged in your request ID. Dex is specifically a little bit different. As you can see in the body itself, it is creating a request. Not a lot of OAuth servers do that, but this specifically does it. It basically says that this is the user who is trying to log in, give him the authorization. So let's just forward this. Okay. So as you can see, I got a code here. So this is the reason why I've got a code right now. Initially in my request, when I clicked on the single sign-on, I'll just show you that a bit. That might be in the history. Yeah, as you can see, I hope it's visible. Little zoom. Okay. I guess. Wait. Hmm. I hope this is visible. Like kind of. No.
Other we do one thing. Go to proxy setting and type message कर दिया. So there you see the font size there. Change it to 17
Okay.
ना पिको. No.
I guess now it's fine. Yeah, good. So basically, this is the exact response or request which you can be expecting from the OAuth server. The client ID, that is the Web 50. It is basically nothing but the web application which I have built. I have a hosted application, so I have given a name as Web 50. So it is a static thing, and it is not, if you find something like this in JavaScript, it is not, first of all, a vulnerability. I've seen a lot of people, I don't know why they report client ID. So this is one of the things which they ask for. Then goes with the redirect URI. So redirection URI is basically you are telling OAuth server, give me authorization code or access token on this endpoint. On this endpoint itself. So once you have shared this request, it will go with the OAuth server saying that give me endpoint, and then there is a response type where I have mentioned code. So now the authorization server is throwing a authorization code to my web application. And after that, there are the scope, which I said, which is one of the vulnerable things, which are when you actually define a lot of things in scope, you are giving a lot of permission to the application. So this is one of the things which I was talking about. And then, okay, I hope this is clear. Yeah, great. So yeah, so this is how you have created you got an authorization code. I guess this will be expired now, but you got a code. Now if you forward this, or you just set that and you go back to the application, yeah, you have been logged in. Now what happened? You change the code. Now OAuth server will return access token, refresh token and ID token if you are asking for open ID, or else it will return access token and refresh token. That is the main thing. So this is how actually authentication works in OAuth. Okay. So a lot of time, as I said, not every time you are going to deal with third-party OAuth servers. A lot of time there are in-house OAuth servers as well, which are more vulnerable. Yeah. So let's go back to the slides. Okay. I hope I cleared your doubt. Yeah, great. So this is the exact flow, how I explained about the OAuth. And after this, now the main thing, that are the grant types. So this is how the OAuth server decides to provide you access to the application. So these are some of the 5 access grant types, out of which these 2 are deprecated. If you found these working, I won't go randomly say and just report it, but these are some of the deprecated ones. I will say at least flag it to the people, saying that this is a kind of informational finding, saying that don't use it, rather go with the above 3 or anything else. So I will let you know and how to identify what kind of grant types the actually application is using right now. So these are the 5 things, that is authorization code with PKCE. Now first I'll explain you what is authorization code. The thing which I did in my application was authorization code. I asked to respond with a code and I exchanged the code for an access token. So this is the process which I did to maintain a authorization code. But what is PKCE then? It is proof of something key code exchange. So what happened in that? There is another parameter included in your request, that is code verifier. Now when the server returns a code, now you want to check whether the code is legit or not. For that, the client will add a code verifier in the body, match it with the code which is written by the OAuth server and again send it to the application. Now if it is implemented properly, only after that you will get the access token. If the code verifier is manipulated, boom, you won't get any access token. It is built, it will be rejected. So at that time, it is this one is the most recommended thing which you need to use as a authorization code grant type. Then goes down, there is a client credential grant type. So this one, as I said, no user interaction is needed. Once you have logged in into the application, done. This is not the login part. It happens when there are some of the internal APIs the application wants to fetch, or some of the sensitive APIs the application wants to fetch. Anything. It can be any internal information or any third-party APIs. At that time, what the application does, they create a secret and uses their client ID and match it. It's shared to the application, and only after that it is being performed. So that code means repeatedly moves in your application for 15 to 30 minutes. It fetches the APIs and give you the information. So user interaction is not needed. After that, this is the device code authorization grant. You all would have seen this. I will explain you what it is. You all would have seen device code grant when I'm actually into that topic. So right now we'll focus on implicit and resource owner. So these are 2 deprecated. So why it is? The very first thing, implicit will send the access token in URL, which is not recommended. So if the implicit is sending it in URL, it is obviously stored in your history or it is cached. So any user which is actually into your browser can easily take that access token. And as you can know that JWT have a very high, what you can say, expiry time. So if they got the access token, they can do anything. So basically this is one of the things deprecated. And the last is resource owner password credential. So this is not used by, yeah, go ahead.
So duplicit one I have seen multiple times from retest. I am able to see. Sorry, in the response I'm able to see, or in the request I'm able to see the JW.
Yeah, exactly. So that is what this sharing the sensitive information in your URI parameters. So that is one of the vulnerability. Why I am asking you to go for informational, because you can exploit it completely. It is a thing like if there was a insider issue, insider threat, then they can access your browser history or they can see your tokens.
Yeah, I said it. That is also one of the things which can happen. They can monitor your traffic.
Wireshark or anything on the network, they can monitor it. So this is one of the things which I actually initially told to be reported, as it is deprecated as well. And a lot of service providers. I was recently trying to build up a lab using Cognito. So I have figured out that Cognito itself says that don't use implicit. They're providing it, but they say don't use it. So this is one of the things which has been deprecated. I can say I don't know the exact date, but I will say years back, because Cognito initially was able to do that when I was initially building it, but recently when I started to build a lab again, now they are saying that don't use that or it is deprecated, something with the red signal. So I don't know the exact date. You can Google it. It is simple. You will find it. But it one is deprecated because it is breaking the exact rule which is built for the OAuth thing. Then the second one, which is also doing the same thing, but not the only passing credentials or sensitive information in URL, but it is breaking the complete logic of OAuth. So the main logic of OAuth is the application or the client shouldn't read your credentials. The service provider, the OAuth will do that and they will provide you access. But in this case, what happened? The service provider every time asks you to pass on the credentials. So in this case, what happens? The application verifies that, and after that, they will ask for the code on the basis of the credential. So it is anyways breaking the complete OAuth logic. So this is why these two ones are deprecated and are not supported to work. In case if you found while you
This. Was it like the resource owner password credential required you to log in via OpenAuth every time you try to log in your account? Is that what you were saying?
but not to the service provider by the client application. They pass the credential to the client and ask the client server to verify it with the OAuth. So that's what happened.
So the password on the code would be stored on the client.
Yeah, exactly. So that's breaking the complete logic. So this is one of the things which happens in resource owner password credential. And these are the two things. Any questions? So I solved it out. Yeah.
Yeah. For the first point, comparison, we said something about the verification.
Yeah. So basically, authorization code. What happens? You have shared your credential to the OAuth server. It will return a code if you are added a request as a code. So once you have requested a code, the client will give you a code verifier parameter that is added by the client, not by the OAuth server. It is added by the client. And whenever the code is fetched by the client, it will match both. It will create a verifier and it will send it back to the OAuth server. If it matches, only after that the access token is shared. Or else, yeah.
What is the use of this? If I don't verify them up, it won't give you access to them. But this is some configuration, correct? That yeah, beep set follows.
Yeah. Then there is a misconfiguration. See, what happens? Some uses authorization code. Some uses authorization code with PKC. So this is one of the things. So these are two different things.
So in PKC, one only the verification.
Yeah, exactly. Not in the normal one. So a lot of times you won't find something like that. If they have implemented something like PKC, that is proof key of code exchange, only after that you will see something like code verifier as a parameter passing in your body. So this is one of the things. Okay. I hope everything is clear. So let's go ahead and understand what exactly is authorization code. Actually, I have already explained this. So PKC, that is a proof key of code exchange. So basically, you will have a code verifier, and in some cases, you will get a code exchange. This is an optional thing, but a lot of time when you are into a security background, you get these kind of things as well, that there is a code challenge. It is nothing, it is simple as a code verifier, but it is you will see another string which is getting passed. So it is not verifying it, it is passing another string, something like making the request unique every time. So that's the reason this is one of the things which you will see in the authorization code PKC. So what is the flow for that? It is simple as authorization code. The only thing which will be added is a code verifier over here. Everything completely will be similar to the authorization code part. The PKC just adds a code verifier.
But the code verifier is constant.
Not a mouse.
In some cases, if it is misconfigured, yeah, you will always see a same what you can say code verifier. But a lot of time it will be matching with the code which you got from the server. What it does, the OAuth server shared you a code, okay? So it matches the same code verifier which is present in HDB, and then it share it to the OAuth server to get the access token. So every time, if it is configured properly, every time you will get a new token or a new verifier. And if it is misconfigured, yes, you will get a repeated one. So you can easily store it and use it for the next request. So this is one of the attack vectors as well. You can remove this and you can try if this is misconfigured, if they are using PKC, but it is not. The reason is this is done by your client web application and not the OAuth server. So this can be misconfigured a lot of times. Okay. Then go ahead with the client credential part. You are accessing internal APIs, then you will find OAuth servers which are built by the internal people. And if you are trying to fetch some of the APIs which are sensitive and which are third party, so you will find OAuth server using client credentials which are can be Microsoft or anything. They will be fetching the information from there and they will be using secrets. A lot of time if it is using Microsoft, then that will be secure. The reason is the only attack vector for this is to brute force or to crack the client secret. So a lot of time if it is using third party, they give a long string which is, it will give a billion years to get brute forced. And yeah, if you find something like that in JavaScript, then yeah, gold. So let's go ahead. And this is the exact flow. Similarly, your client application is trying to fetch APIs, and now the APIs are actually throwing you to the SSO. And this is happening auto. You don't need to go and enter any credentials. After that, it will share client ID and secret, and the OAuth server will fetch the access token. In this process, you will get the information and APIs whichever you are required for that from the third party or from the internal sources.
These
So-
are mostly used like some operations or
Yeah.
something, not manual.
Manual in some cases. In what happens, let's see, there is an internal application and there are some portion of that which you are publicly hosted, and now you need to fetch information which is not public. You need to fetch it when you are it is in the internal information. So at that time they use internal OAuth servers which does this for security reasons. A lot of time auditors ask you to do this as well, to implement OAuth whenever you are fetching any kind of information. So that is one of the client trick. Then going ahead with device code. So as I said, you would have seen this a lot. Every one of you have used Netflix, and yeah. So yes, everyone, right? So what happens in device code authorization? So you have been logged into your TV, and now let's see you are opening any of your OTT channels, goes with Amazon or Netflix or anything. So they will ask you to enter this code in your device, and then it will be redirected to your application. You are logged in. So basically this is using device code grant. So and how this is vulnerable? This is not vulnerable to any attack, but it is basically vulnerable to phishing. And it is a very legitimate phishing. The reason is, in main phishing attacks, what you do, you create a fake template, web application template or any template which you want to phish for. But in this case, you don't need to do that. You completely follow the authorization process and you get the access. Now, what happens with this? I'll explain you. And not only on your side, but in corporates as well, you will see a lot of conferences happening and they're using TVs. So there are some of the applications which are built to perform these kind of things when you are integrating with it. Going ahead. So how it flows. So now how an attacker can perform a phishing activity on it. So I'll just explain you the flow first. You have turned on your OTT channel, you got a code, you are entering that code, and now you're logged in into your application. So now everything happened properly. Now what happens? Client ID is the only thing which is required by the attacker. And as I said, client ID is available. It is, if you go and you smurf the network, you will find some of the client IDs going to that application if they are trying to log in. So what an attacker does, what an attacker mindset does, everything will be legit. The attacker will come, they will get the client ID of the victim, they will add it to their request, they will curl a request to the OAuth service provider. And now what will happen? Service provider will think the legit user is trying to curl the request, and they will send a code like this. They will send a code like this to the response body. Now the attacker will take that code and create a phishing, I will say a page, I won't say an application, a page, and add that code and send a legit Microsoft or anything into that phishing box and ask the user to complete the process. Once the user have completed the process, the person who have actually asked for the request, the attacker, will get the access token and not the user. So at that time, if the user have completed the process, the attacker who initially did the request will get the access token. And now you might think that, okay, so everything is legit, then what is the fix for this? So as I said, the scope thing, the main attack which happened on this device code was regarding the Microsoft scope. Initially, when Microsoft has organized the code credential grants or a device code credential grant, they have given everything in their scope. So whoever access token from any sources goes with any of the Netflix or anything which they are using over, they can use it anywhere in their Microsoft, use Outlook or anything. So what happened in this case, the phishing activity performed, the attacker got the access token, the scope gave him everything. Now he was able to log into the victim's Outlook account, other Microsoft channels and everything. So this is how the device code credential flow actually works. So yeah, I hope this is clear so far. Okay. So this is one of the things that implicit and ROPC, which is the deprecated ones. It's not suggested to implement these kind of authorization grants on your OAuth. So as I said, these are the exact issues which happens when you are implementing these deprecated OAuth flows. Okay. So yeah, so the flow is simple. It is similar to all the other OAuth flows. The only thing is in this, the request type won't be your code, it will be the access token. And it will be directly passing the access token in the URL. And that's the reason the implicit one is not being used a lot. Going ahead with the resource owner password credential, the similar things, but you need to sign up every time with the user pass. And after that, you will be able to log into the application. So you are actually storing the credentials at the application side. Now, part for the live demonstration. Yeah, a lot of time it breaks. So let's go ahead. Further. So for this, I'll be explaining 2 demonstration. But before that, everything is clear till now. So I will just give you a real world explanation about what the attacks I'm going to show you. Everything clear so far? No doubts? Great. So we'll be showing 2 demonstrations. That is, first is OAuth account linking. That is to perform a CSRF and account a user, means link an user account to the admin account. Now whenever, let's see, an admin has logged into an application and now a user is also logged into the application. There is something as accesses on that application and I shared a CSRF link to link my OAuth to that admin. Now what happens? When I am trying to log in, my user who is trying to log in through via SSO, I will get the access of the admin session. So this is basically the account linking part. And then the second is the client confusion attack. This is one of the rare things which happen, because even if you are a vibe coder, it will give you GPT will give you a right code to build it, but still it been misconfigured and you might have missed this test case because we believe that this won't happen at the first place, but I'll show you what I'm exactly talking about. So let's go ahead and do the lab. Okay. I hope it's visible. Everyone back there? It's visible? Yeah. Great. No doubt so far, right? Anyone? Great. So I'll just terminate this first. I guess it won't be there now.
Could you give an example or of an application where these 3 recommended approaches would be better used?
Okay, so The recommended one for the first one is that is authorization code with PKC. That is basically the SSO login. If you are an end user, you are trying to log in into an application, it is expected to use an authorization code or authorization code PKC. That is which is one of the recommended one. The client credential is specifically for the applications which are fetching information from the another APIs. It does not have the information right now, but whenever you are asking for that information, it fetch from the different source. So at that time, they are actually trying to authorize to that particular application. For example, so for example, there are two applications. Don't take it as a one application. There are two applications that are using multiple APIs. Now your application requires request or something resources from other application. Okay, at that moment you need to authorize to that application, right? So for that they are using client credential grant. The reason is, if it is not used, your JWT or your access token which is recommended for your application can be used for them. So they don't require that. They will ask you to share the secret and client ID. Only after that you can fetch the information, or else you won't. This is the process. I guess there is a doubt right now. You can ask.
What is the cost? What guys?
Authorization code.
In both the cases, are we not collecting information?
So the thing is, the first part is for the SSO and not for the, what you can say, see, this process takes a time, what you can say, the cache or something like it goes up with the time. So client credential will do it really quickly rather than depending on the authorization code, because this process is to be done automated and not by the user. The client credential is not passed on by the user, it is passed on by the application.
We say in one way that for you're trying to do client credential, the application server will store the secret ID or something. Yeah. Only once. Yeah. To collect the authorized information, and then the authorized information is stored and associated with.
It is not stored. In some cases, they might store it in local storage, but they are just using it to show the information. So every time when user is trying to access some kind of APIs, it is always asking from them, and it is not happening in front end. For example, if you see something,
But in their own application server, only that will be stored. They won't have to again request the other person, like the other third-party application which we are referring to. For the
so you are saying that if the application have initially stored the data, they don't need to require to. So if it is stored in local storage, it means if they are storing it in the local storage, if it is not happening, then they need to again do that, right? The syncing process. If it is not storing in the local storage, then the API need to again call the client credential and then perform the attack. Perform the flow itself. So that's in that case, if it is storing in local storage, at that time it will be refreshed and you will see the information. But even if it is doing it for the first time, you will see something like client ID and secret which will be transmitted in your request. So at that time you can try to use it or break it. That's the process.
question was in the sense, yeah, because since both PKC approach, okay, and client credentials seem similar. And you mentioned how for the first case in the PKC approach we did for single sign-on, where we read explicitly the account and the account's credentials to be in a safe way stored in the application, so that the user can be represented by this account.
Okay, but that is completely on authorization server. It is not on the client. Okay, that is on the authorization server. Yeah.
I'm not talking browser side. I'm speaking about the difference between authentication and authorization. The implementation perspective of these two open protocols or like measures. So is it that for the first method you need to repetitively do the process, and for client credential you could potentially do it in a limited number of times?
For the first process, okay, so you are saying that in the authorization code, once you have logged in into an application, so you need to repeatedly log in into that application, or it is enough that. So yeah, so what happens in this case, this is the browser thing, this is not the application side. So now let's suppose you have logged in into an application, you are using a single sign-on, you are using authorization code as PKC, and you have logged in. So now you don't need to log in again in the same session. But if you're using a new session, you need to sign on with your credentials. The reason it is not taking from the application, or it is not taking from the application, it is taking from your cache server. It is not taking from the application at all. In client credential, whereas the secret and everything is stored within the server and not the cache. So every time when the API is hitting the third party server, it is actually using the secret which is stored, which is lot of time hidden, and then you can fetch the information.
Such, yeah, board.
One question. So normally first case, where you need to give a prediction. See, and it will not go to your client, right? The client server. It will not go to your server. It will directly go to the
OAuth, yeah, as a provider. Yeah.
from there you will get the token.
Yeah.
Have some expired, maybe 1 hour, 2 hour, something. But for other case, which is the client one, oh yeah, I don't know the client credential, yeah, flag origin. So in that case, there is no expired access for that. Oh, there is no expired. There would be, but it would be a longer expired, maybe a month.
It depends. It depends. The thing is, in that configuration as well, you can add a refresh token. So a lot of time, if the expiry is, let's go with 1 hour or 2 hour, the refresh token will be auto generated in your browser, or I will say in your application itself, and then you'll get a new access token from that refresh token. So that is the process.
See, mostly if I think it in a way, yeah, in generally where I have seen the first scenario where the tax span is like the expiry time is very low, and then in the second case the expiry time is quite high, so that we are able to do automations that are by see. Yeah, and what if they come and try to some task which is very which might take a day of time, and suddenly the session expires, that everything was hard again for the IJP. So that's the reason we give them all the
That's perfect. That's perfect. That happens. That depends on the your use of for that application and the APIs which you're fetching. What is the exact use for it? So if it is actually being used for a long time, then developers do a things that they don't even expire the JWT. Sometimes that happens.
like the second scenario is very much similar to API.
Yeah, exactly. It is similar to the API keys part. Where rather than API key, you are using client credential. Good example. I got out of that mind. Yeah. So it is similar to the API key part, the client credential. Rather than the API key, a lot of auditors might ask you to implement credential grant as well. So I hope it's clear. So let's go ahead with the lab part. Okay. Okay. No containers are running. Fine. Okay. So I'll just log out. Okay. So let's authenticate. So now first I will go with the OAuth account CSRF account linking. So what exactly it is and perform that attack. Okay. Okay. So it started. Okay. So now let's go ahead. So the main motive for this lab will be what happens. I will just explain you what happens in this case. A lot of time applications build their own authentication authorization. They ask the user to authenticate, but after that they will also give you an functionality that you can link your OAuth accounts or you can link your SSOs to the account. So in this case what happens, the clients or the web applications authentication is different and the SSO authentication is different. So now if you as a legit user have logged into your application and you have this to link your OAuth account to your user ID, there is a chance to get a CSRF attack over there. So I'll show you how you can do that. So for that, I'll be showing you with the two labs right now. Localhost. Okay. So in this case, I will log in as an admin. I'm completely using a Dex OAuth server. That is the open source one. You can check that as well. It is great. But if you're implementing it properly. So I guess, wait a minute. Yeah. So I have been logged in as an admin right now and I will show you how you can perform a CSRF attack and link actually to the account. So for the another session, I will log in as a user. Okay. So there are right now 2 sessions in the same application. One is user and one is an admin session. And our task is to perform a CSRF attack and link the user's single sign-on with the admin session. So how we actually do that? So you might get an access something like to link your OAuth. Obviously, it won't see like this, but you will get some functionalities which you can integrate with your SSO login. So at that time, as I said, there is something called as authorization code which has been used. So you can actually exploit it. So I'll just show you. I'll use user, and now linking my own user account, user SSO to my user authentication itself. So I'll just open it. Okay. Now I will intercept this traffic to get the authorization code request. Okay. I hope everyone is familiar with Burp Suite. The ones who are working professionals, they will obviously रोज का ही हो गया. So yes. Now I will intercept this traffic. So as you can see, it is actually saying that this is the request a person. Now it will share me the authorization code. I'll forward this request. Okay, again. So as you can see, I got a code right now. So what I will do, I'll just share this, send it to the repeater, and I'll drop the request to keep it unique. The server have given me authorization code. Now this is unique for each user. So server have assigned this authorization code to user, and now it is unique. So I will drop the request. Okay. I'll turn off the intercept. I'll go back. Okay. I will not do that process completely. Now, as you can see in the repeater, I have the URL, which is the authorization code. So now it is not used yet. So what I can do, I'll just copy the URL. And there might be something like XSS on your application, if you found that, or else you can simply perform a CSRF attack as well. So if you are using it, I'm just chaining it with XSS to look better. So you can do that. You can just create a simple shref equal to this. Okay. Okay. So the user have been shared something like this in the chat. Now let's go into the admin session. The admin is logged in. Okay. So as you can see, the admin has been logged in and the user have sent in something in the chat. So what happens over here, if the admin clicks on it, something comes into the request, and now what happened, the user's OAuth account has been linked to admin. Now how you can prove it? Just go back to the user session. Okay, I'll log out. Now I will try to log in via my SSO, that is user grant access, and as you can see here. So this is how you actually perform a kind of CSRF attack, or means via XSS to get the account takeover. So this is a complete admin account takeover and via CSRF attack. So this happens a lot into the authorization code part. You can do that in the implicit part as well, but the thing is, it is all about the access token. So if it is better to get the authorization code, only after that you can perform a CSRF attack.
Okay.
How can so yeah, this is a good question. So I'll just show you. So I have told you in the slides as well, there is something called a state parameter. So as you can see in this request, the state body, a state parameter is passing, but it is empty. So what happens, it is basically nothing but a CSRF token for OAuth. So it is making your each request unique. So if I'm using this again on a same request, it will give me, okay, it has already been used. So this is basically developed by the client and not the server. So obviously your browser will say that this CSRF token is already been used. So that's the reason it won't be happening.
I make this request as post at that time. So instead of get up, because it's sending it via like a phishing link or something, the user app.
In post request also we can perform CSRF. In same case, we can in the post request also we can perform CSRF.
Via this method, I'm talking about anchor tag revenue RTSS.
Okay, so you are saying that if you do this, change the request to post, and then there is a code and everything like this. Are you saying like that? This is the same post request, but the every parameter which was passing in the get has been turned to the body. So you are asking this?
Me, you're going to set this in your browser. Pick at the
So basically, this won't be shared as a link, but yeah, you can perform this attack by sending the POC itself. So basically, as an pen testers, and then CSRF POC, and we can create and we can share it. Via XSS, yeah, you can do that, but for that you need to perform a Java, means you need to write a JavaScript code for that to do a post request. Yeah, to do a post request. That's the thing. So that is also possible, but only in the case if it is not using the state parameter. Yes. So this is one of the fix for this type of attacks if it is using, if it is not using CS.
So this should be implemented by the SSO provider or
The post logging or the state parameter. The client will do that for, yeah. The state parameters or the NONC, nonce parameter. There is two kind of parameters. Most of the time state will be implemented. The reason is if the SSO have done that and it is shared to your set to your browser, it is similar to the OAuth code itself. So it will be signed to that user. But if the client have given that what you can say the state parameter, then it will be unique every time.
correct. But can you explore a little bit of Veritas? Yeah. So yes. Yeah.
Yes. This is going to a client. Basically, wait a second. Yeah, this is going to a client. Yeah, exactly.
So can we do this without XSS or CS attack? Like there should be a condition that for this attack, either XSS or CS attack, application should give a
Yeah. If in case if it is not vulnerable to XSS, if it is not using state, it will be vulnerable for CSR. Because state is the only patch for the CSR mitigation on OAuth. It is working as a what you can say your CSRF token specifically. So if it is not working like that, you can perform an attack. But as I said, you require 2 credential SSO logins for that. I hope this demonstration is clear so far. Any doubts so far?
Why was it initially possible for users, like for the admin user to connect to the admin when admin had clicked on it? And then what user passed this link
Wait, I've logged into both application, one admin, one user. Okay. Then
from admin side. User passes this malicious link on the chat box. Admin clicks on it. Yeah. How does user get the access? Why wouldn't the admin get user's access? Why would it?
because I am using the authorization code of user. So what I did, I'll again show you. So what I did right now, as you can see, I'm logged in as admin. Okay. So basically, okay, I'll show it here itself. So basically, user. So now I've logged in as user account. I'm trying to link my user account, my user SSO to my user account. That's the thing which I'm trying to do now. So just, okay. So I'm passing my own credentials, which is my SSO login. Now, when I'm trying to log into that account, so I'll intercept it. So this is what is actually happening. So this is what is actually happening. So this authorization code is sent by the OAuth server for the user, not for the admin. So now user used his own ID, send it to the admin clicks on it, and his user account is linked to the admin. So if admin has done that, the admin have shared his OAuth server means authorization code to user and user have clicked on it, then admin account would have linked to user. So that's
Initially the code was created for the user. So the code the data should have been associated with the code should have been for the user.
That's not the case. What happens in web application, there are APIs which are used by both the users. So even though if it is using authorization for user, an application have loaded that request in his browser, then admin can be linked to the user account. There won't be any other issues for that.
So this code is actually just sort of like an API key which you was.
Not the API key exactly. This is a part where the user have passed his credential and he gets the access for this code itself. If admin does it, he will also get a code. That's the process. So if user is using his code on admin account and link it with his own account, then he will be getting the ultimate admin account. So anything clear?
One mitigation can also be that I do a mapping. This is the port. This is mapped to this user.
Okay. That happens, but it happens if I've dropped the request. As you can see, I haven't used it. So if I've used it, then that thing can happen.
Get tweaked. I set the request to the server. As provided. There, I will be doing some processing. You generate the particular board. Zone generation inside either port at the client. He can do a mapping that this port is this particular.
Yeah. That can be done. That can be one of the mitigation, but it is at the OAuth server side. If it is using a third party part, if it is in house, you can implement that at your own. Yeah, exactly. That is also one of the things you can do. So I'll go with the another attack which I have seen a lot. I'll move on. But before that, yeah, is it clear? So, understood. Okay, fine. I'll just clear it out afterwards. Fine. Let's go ahead. So now we will understand about the client. This is the CSRF part, which we are linking your user account to the admin and getting the complete admin account here. Now the second one is client confusion attack. Now this is one of the rare things which I already said. Even if you are just 1 minute, I'll just down this thing first. Okay. So yeah, client confusion attack. So what exactly I mean by this? Running properly. Yeah, fine. So in this, it's basically stealing a token and then pivoting into multiple applications. So I'll explain you the logic behind this. There is an organization, they have built multiple applications. They are using the same OAuth server for every application. Now in this case, client confusion attacks comes into picture. What happens? Every client or every application should have their unique client ID that I mentioned, that can be Web 50, Web 1, anything that is your unique ID should be given to the application. Now what happens in server, in the client application server, not the OAuth, there is a logic which is verifying the JWT. In that, the logic should be verifying the OD, that is your client ID, as well as the ISS, that is the issuer, means the OAuth server. These are the two things which are actually being verified by the application, should be verified by the application. If it is missing, then easily, if you are able to compromise one application, you can use their access token and pivot into multiple applications of the same organization. So this is one of the things which is actually used to pivot into multiple applications itself. So I'll show you the demonstration part. Okay. 3001. Okay, I'll just log in. In this case, I've already have admin and user for both the accounts, but I'll just show you what I mean by pivoting. So let's see, 3000. So there are two applications right now in the same, that is, one is hosting on 3000 and one is on the 3001. Okay, so these two are different applications, but both have a logic saying that they are not actually verifying the OD, that is the audience given by the OAuth server. So what exactly is that? I'll just show you. Okay, now I have logged in. User. I'll just go with the admin, I guess. Example. Okay, and you get something like this. So now similarly, I'll log in as a user account over here and give admin. Okay. So it is using the same grant type, nothing regarding to the grant types over here. We are not exploiting the grant types. We are actually looking for the logic which the client server is misconfigured for. That is the OAuth server. So what happens in this case? Similarly, if there are any type of excesses, majorly it is required the excesses attack to get this token. The reason is if something like this is stored in your local DB, that is F12. Okay, So there's an access token which will be stored in your local database, which is not a good practice at all. So in case if you found accesses, I hope this is clear, means visible. So basically, the user's access token have been stored in the into the local DB. So if you got any kind of XSS vulnerability on the application, so the odd misconfiguration is nothing. If you are able to exfiltrate this JWT, then you are able to perform on pivot to another application from the same organization. So how will I do that? So for that, I'll just show you. Like, so I've already wrote a code for that. So yeah, so this is one of the JavaScript code, as I said. So what it will do, it will take the JSON stringify local storage. So whatever stored in the local storage, it will throw it for me on the data, that is for the exfiltrate, which I'm trying to exfiltrate for, and this is the location where I want to exfiltrate the data. So if the CSP and everything is not in place, then you are easily able to do that, or you can easily bypass CSP and try to perform these kind of attacks. So in this case, I'll just use this code. We'll see. So I'll just break down this, what it's actually doing. It is using a JavaScript, building up a function, having an object, that is a document, create an empty element, and using that empty element to add the whatever payload or whatever thing is stored in the JavaScript or in the local storage to your hosted server. So I'll use this. Okay. And now, okay, I see this is still done. Okay. Wait a minute, I need to log in as an admin as well to fetch the information. So okay, so similar case, nothing much, no much difference. The only thing is the payloads are different, the condition is different, that is the only thing. So what happens here, I'll be using the webhook URI. Okay, I'll just replace it with the original URI. Till you. Okay, I guess it's done, and send it to the so now you can see the normal user have sent a link. So if an admin is right now logged in and he found it, so and I'm trying to access it. So what happens over here, you can go up and yeah, so as you can see, you're able to exfiltrate the data. So this is the complete data which will be exfiltrated. Basically, I have exfiltrated it in a base64 format. So you need to decode it in base64 and then you will be getting the access token. So this is a condition where one application of an organization has been compromised, but you should not pivot with that access token to the multiple applications of the same organization. Not the JWT, that is a base64 encoded part. I'll just decode it and I'll show you. It is basically everything in the local storage. So it took everything, base64 encoded it and exfiltrated it properly. Yeah. So I'll just show you. So Control V and then decode it. So over here, as you can see, this is the access token. Okay. So we were able to exfiltrate the access token and everything. So if I'm using the same access token, now I will log in into the first application where it was 3000. I'm already logged in as admin, but if I'm actually, I'll try to log in with user itself. Let's see. Okay. Inspect. Go with the local storage. And this is the JWT. I'll replace it with the ones which I found, and let's copy that first properly. Yes, sir. Copy, and I'll replace this with the JWT. Now if I refresh this and it is session has been stored, then I am able to log in as admin from this application. So what exactly is the misconfiguration? I'll just open the source code and show you that you will understand better what happened over here. So this was completely because of the misverification of the JWT token. This is not at the authorization code part, this is the client server part. So what the issue was? Okay. Okay. So this was the part. Yeah, as you can see over here, I guess I need to zoom a bit. I hope this is visible for everyone. So what happens here, it is basically verifying the token. If it is a legit token itself, it is verifying the header part of the JWT, that is the RS-256, and decode it, see the payload and everything. But there should be more two parameters mentioned, that is the odd and the ISS. So what it is, I'll decode the JWT and show you, so you understand that better.
So this code is for 3000 application, 3000.
3000. Yeah, so it is, yeah, the vulnerable one. So in that, it's basically not using the two things, that is the odd and ISS. So odd is nothing but the client ID, which is used by the application, and ISS is basically the issuer. It is the, in my case, it is DEX. So it, in any other, it can be any other OAuth service provider. Okay. So going back to the decoding part of the JWT, copy this. So over here, you can see this is an odd and IS mention over here. I hope the screen is visible. I don't a bit. In the payload, you can see there is an odd and ISS visible. So if this is not verified or checked by the your application, so anything in your organization, there are multiple applications, any JWT from any application can be used for anything. So that's not should be in the first place. So this were the two attack vectors which I usually look for in a OAuth authentication. There are more. It is not limited to them. There are more attack vectors, but these are some of the primary which I actually go for. So I hope everything was clear. Any doubts so far in client confusion or CSRF? Anything? Anyone? Yeah.
Why do one have to make the second attack? Just K-Hauser.
That depends on the organization, I believe, because a lot of time there are internal applications, multiple internal applications or multiple applications hosted publicly. So same organization, let's see, Redfox, let's take Redfox. We are using multiple applications, again, academy, security, everyone has their own login. So they might be using OAuth, they're using the same provider. But there are multiple applications, it can be a bit a domain difference. So they're using different client IDs. So that is one of the case which happens. Not always, but yeah, there is one of the case which happens like this.
So because with the 3000 on application, yeah, I was able to log in for log into admin account of 3000. Yeah, you are at third. So I already have the JWT system. Yeah, I can directly log in 3000 application need this by I.
But every application might be that user have different privileges. Let's see the login you have into and you have compromised an application and you have took any, not only admin, I'm saying any other user, and he have different privileges on this application, and the organization have another application with the different privileges for the same user.
So but this will not allow me to get admin privileges in 3000. What?
No, why not? You already took the token from the 3000.
3000. How's it? I
Logged into 3000. My vulnerable for accesses were 3001. I logged in into the 3001 as user. Okay, I performed accesses. I exfiltrated the JWT of the admin account of 3001. Yeah. So now if I'm using that 3001 JWT on the same application, I will be able to access the APIs. And if I'm using that 3001 on any other application of same organization, still I'm able to do that.
but in 3000, will you be able to get admin access of 3001?
That depends if it is vulnerable and if you are able to exfiltrate the data. If 3001 is verifying that odd and ISS, not. If it is not verifying, then yes.
Naresh, it is how you are so shown 3000.
He is not verifying the odd and ISS, so I'm exfiltrating the data from 3001 and pivoting it to 3000.
Okay.
That was the case. If in case the 3001 is not verifying odd and ISS, I will be able to do the same thing from 3000 to 3001.
Well, maybe you have access to one instance. You are able to get you are able to log in to an admin account on the same place. We can
Why not? We can. See. I'll explain you. I explain you. So you are saying I have logged in into 3001. So you are saying same instance in the same application. I'm not able to log in as an admin. Are you saying that? I'm not getting the question.
for example, let's make it currently now.
Yeah, very.
Let's make it ABC and XYZ. So ABC application, I am a user of that application. Yes. So I have it. I have exfiltrated the zero up it up app. So I have the this is ABTVC. Now I am logged into XYZ application. Yes. Where I am able to replace the JWT with the AB's application. This is how it's XYZ.
So you can do the same thing in the ABC as well, no?
Yeah, but the thing is, I will not be able to in XYZ application. I will not be able to escalate it to admin of XYZ. Okay. You're saying it could already be why to start.
It depends on the privileges of that user account which you have compromised. If it has the admin privileges, you are an admin. If you don't have the admin privileges, you are a normal user. That's the thing. It's not always the admin thing.
So let me even Ratul. So let's say that in the ABC application, the role of the user is admin. The role attribute is set to admin. And if you are using the same JWT token on the other application, the source of truth is same, the identity provider. It will also think that the role is admin. Yeah. It is going to the admin in this application as well. So it depends the role. So if it is a normal user, then again other applications the same as team user might have admin privileges. Right? It depends on the application to application. You get my point? So let's suppose there is a application ABC, there are two roles, super admin and ad. And in the other application, the role is just admin. Okay? So it will be a compromise the admin user in this application and the attribute is set to role equals to admin. Okay? Same attribute you there in other. It also thinks that the role is set to admin. But in the application, there is only one admin role, which is the superior role. So the same user with the admin privileges in this application becomes an admin in other. For learn is same in both application. It also depends on the logic of the other application. How that application is splitting the both in that.
It is completely dependent on the privileges of that particular user. If you have compromised an admin user of your application, it is not necessary that it will be the admin of another application, but at first place it can be. Yes, it can be. That's the only thing. If it is, then obviously you are able to take the admin account and most probably it will be. The reason is if a developer is building up an admin user, they are passing it to all the applications. That is one of the logics which I've seen a lot of developers doing. So I hope this was clear.
So the JWT tokens of the second application, 3000. Can I make it side by side instead of a way?
Okay, Newta. Okay,
Yeah,
fine.
I just wanted to compare.
Okay, fine. Great.
I say,
The odd. Yes, odd is different.
yes,
This is Web app 50. So even though it is you having this thing, I'm able to use the another application JWT on this, and it is giving me the process. As the ISS, this is basically what? The public key. You are signing it, the application, the public key. The ISS is nothing, the public key which is being used to sign the JWT. So this will be always constant. Yeah. And in this case, I am using the same OAuth server. That's why you're seeing this. A lot of time it might be that that person is also using something different. So this can be a debatable.
Because a backup this is so suppose I have you are continuing provide in a way you can say that so it or you have the blackers with the ABC and XYZ. ADC has 2 websites. XYZ has 3 websites. Yes. So ABC ones will be having the issuer, not the issuer, the AUV has same all the 2 websites to have the same name.
No, there might be different. The reason is, the domain or the client's requirements, according to the client's requirement, it will be different. Yeah. For example, the clients are asking that the applications are same, but they want to host it simply. So they might add up a same audience or the same client ID. But if it is a complete different entities, then at that time, client IDs are different. And if the another application, it is completely different. If you are asking from another company, I'm able to pivot in this, then that's a case. That is actually a case that happens, and that was a great. I will just show you some of the references. That was a cyber attack which happened on the OAuth, reflecting the same. And in that case, it was not even identifying ISS. So the third organization which was using the same OAuth server, basically, if you are using Facebook, done. I am able to take your account. That was the case in 2023. Now it is patched. So how it patched? There was a clean thing that is user pool, if you have heard about in the Cognito or something like that. So what happens whenever you are integrating an authorization or OAuth, you are basically creating user pools. That is your organization. Under that, there will be different client IDs, and under that there will be your flow. So there is a beautiful attack. You should read about it. It happened in 2023 for the client confusion attack. In that, ISS or anything was not mentioned itself. So yes, so this was all for the labs. I hope everything was clear. So let's go for the prevention part. Back to the slides. Okay. So this was all about OAuth account linking and client confusion attack. After that, the preventions. So these are some of the preventions which you might implement on your side, as well as on the OAuth client, means the client application, as well as the service provider. If you are using a service provider, a lot of time they are actually going with all of this. That is using their own IDs, their own redirect URIs and client IDs. And if you are using an OAuth client application, you need to do all this. So this is one of the things which should be implemented. Okay, I hope this is clear. Okay, so any questions so far?
Application what? Like sir, in the previous slide, there are like one was having a server side one and one was a patches. Or where will we use the together of those?
So client side is basically the web application you have built. You are a client, you have built a web application. So it is your things which you need to do. Server is basically OAuth server, means the service provider which need to fix the issues. Let's see, you have found, which is one of the rare things which is right now happening, that is the redirect URI misplace. A lot of time, initially it used to happen that you change the redirect URI, you will get the authorization code on that redirection URI. For example, there is a hard-coded redirect URI, HTTP localhost 8080. It is hard-coded, okay? But still, if you paste it for 9000, it is sending the authorization code and access token to that. So in that case, it is dependent on the server or OAuth server. They need to fix it. Whereas not on the client side. But the state parameter issues, that is the CSRF issues, that can be one of the things which you need to fix on the client. Then the OD and the ISS thing that you need to verify. And what else you can do for the other attacks? The client secret leakage. The client secret leakage shouldn't be there in JavaScript, or it shouldn't be brute forceable if you are using an in-house OAuth server for client credential. That is one of the things. Yes. So anything else? And one more thing. So these are some of the references which you can actually mark out. The first one, as I said, the million over to take over millions of accounts. This was the client credential and means the ISS and odd misconfiguration one. I'll just open it, you will see it is like OAuth. This person I found it, security researcher, and this was on the Facebook itself, and it is a great article. You must read this. It is superb. And then goes with another is Portschwigger Netscope. Yeah, this is one of my favorites. The device code grant. As I said, you are using any OTT platforms or any other things. So you are using device code grants. So how it is vulnerable. So they have explained it in a beautiful way. You can read this as well. This explains a lot about phishing attacks. So yeah, that's all. Thank you.